So I'm going to encourage audience participation here, at least at the end. This is going to be a much more technical and hopefully a little more leisurely talk than the one this morning, hoping to elicit everybody's input into the underlying causes of some of the trends that we're seeing here as we compare the long-term and short-term changes of soil gas, VOCs, and radon in the same structures. So we're going to go through a couple of case studies here. Got a lot of feedback. I wonder if somebody can turn down a couple of case studies of VOCs and radon in the same structures. We have data sets up to several years long. The hypothesis we're considering here is that radon could provide a cost-effective natural tracer of VOC vapor intrusion. And we want to understand what conditions that might work and what conditions that won't work. This is data collected with the support of US EPA ORD and the Navy's NESD program. So conceptually, we're all in the radon world mostly dealing with this portion of the building envelope, the entry from soil gas, as well as the exhausting from the building through air exchange rate. But for VOCs, that's just sort of the end of the story. Oftentimes we're worried about VOCs coming in from groundwater over the long-term migration over years, diffusion up from the water table, and then advective entry into the structure. So we're going to expect that radon and VOCs will behave the same if we have a well-mixed plenum here and if we have a relatively constant ratio of radon to VOCs in that well-mixed plenum, and if that's the primary place that the VOCs are getting into the building. So I wanted to talk a little bit here, knowing that I'd have a mixed audience of radon and VOC professionals, about what are the differences between the businesses as I see them. The commonly implemented sample durations, 48 to 96 hours, of course, with a preference for even longer multi-month to year-long measurements for radon, because you care primarily about chronic exposure and carcinogenesis. While for VOCs, there's a lot of emphasis in the field on 8 to 24-hour samples. Part of that is guided by the analytical techniques that we have, but it's also somewhat influenced by the concern for both short and chronic exposures. Another huge difference is the cost of the laboratory test. $300 is a good ballpark for VOCs, $10, $11, $12 for radon. Another difference is the capital cost of an instrument, professional grade instrument. Most of the ones out there for VOCs are over $50,000. There's ones in the radon business, I picked $7K. I think I've seen ones at this show down more closer to $2K. Consumer grade monitors. There is no such thing, as far as I know, as a compound-specific consumer-grade monitor for VOCs that's a TCE monitor. There are products on the market that seem to do a decent job for under $200 for radon. The VOC business is primarily for entities that discharge VOCs over time, often large corporations, while the radon business is heavily driven by single-family homeowners and multifamily and commercial homeowners. Another huge difference is the frequency with which we find the indoor air concentration is due to indoor sources. In vapor intrusion business, that is probably more than 50% of the hits in indoor air, exceedances in indoor air, turn out to be traceable to something they bought at Walmart last week or something they bought at Walmart 10 years ago and they didn't know they still had it. While my impression anyway of the radon business is although there are cases where granite countertops, for example, are triggers, those are much rarer than true soil gas intrusion. The business in radon generally starts and probably ends with indoor air measurements, with some water well measurements. Soil gas measurements in radon, I think, are certainly the exception in the field. While VOC issues generally start with groundwater sampling, that's generally the entry point to identifying that there's a problem, and then often proceed to external soil gas or subslab soil gas before getting to indoor air. So they are very different in practice, although the pathway is quite similar. The business elements of the business have substantial differences. Let me get the slides seem to be stuck here. Okay, so jump right into our first case study. Here is what we're calling Virginia Site A. It is a military building in the Mid-Atlantic region. Depth to groundwater is only 3 to 8 feet. The release of VOCs did occur at this building or a building within an easy rock's throw of it. There were historical remediation attempts out here, although they were discontinued back in 2012, 2013 as not particularly effective. So this is a zoom in on a portion of this 120,000 square foot building. What we have here is a series of small built-out areas, office spaces, that are essentially look like what would happen if you built a mobile home inside a warehouse. I don't know if that's the history, but that's kind of what it looks like to walk into it. And so we collected high-frequency data. I'm going to be illustrating data here from this, what we call the supply room down here. An independent space we call up here the supply office. And then I'm going to be presenting data from the women's restroom that is right in there. So we collected high frequency VOC, radon, differential pressure, differential temperature, as well as meteorological data over more than a year. These are the tools we used: the radon eye, indoor air, omega differential pressure, weather station, and we had dual GC ECDs, each with multi-port switching valves. So this is what the subslab soil gas looks like over the 2-year period. Note here we've got a y-axis in logarithmic scale. The general pattern over the first year is certainly very much consistency. Very little variation at each given location. There are, of course, significant spatial variations between these locations. And then a year in, we see substantial decreases happening in 2 or 3 locations, but really no change in others. And these vertical lines are occasions where we did high volume sampling. We put those vertical lines on there because we wanted to ask the question, could we have essentially done a mini mitigation or a mini remediation when we did 2 hours of high volume sampling? And essentially what that says is it's not the sole cause of these green lines going down. It may very well have had a short-term effect, but it's not the sole cause of what those dropped off. Then in indoor air, we have much more temporal variability. So here we're looking at the supply room, and we're ranging from 0.1 to 10 micrograms per cubic meter of TCE. This is an office area ranging again from 0.1 to over 10 micrograms per cubic meter TCE. Okay, so this is radon versus VOC. So blue is TCE. Dark blue is 24-hour rolling average. Radon is in the orange or red, with the dark red being the 24-hour rolling average. Again, we're on logarithmic scale here for TCE. On the right here is radon on a numerical scale. So not nearly as much temporal variation in the radon as there is in the VOC. But then you'll see a pretty good agreement of the trends between the TCE and radon at this location. And what I would call a fairly classic stack effect sort of pattern. In other words, you get a gradual rise here in October, November, December, and a drop off into the summer, and then the same gradual rise again. So that looked very encouraging in terms of the performance of radon as a useful tracer. This just shows it in terms of differential temperature, again suggesting the importance of the stack effect as one potential controlling factor here. And this shows simultaneous differential pressure data at the same location. We see fairly strong fluctuations that sometimes related to weather fronts coming through, for example. And then we took a chunk of this data, about 8 months worth of it, and did some fairly fancy statistics. This is just a correlation matrix that we did kind of getting into the fancy statistics, but it showed that the strongest correlation was between TCE and radon. Also a correlation between differential temperature and TCE. And those relationships also held up when we did more sophisticated time series analysis and machine learning kinds of regression methods, which there is a paper out on this analysis. I think I could make the sophisticated slide advance work for me. Okay, so this gets a little more interesting. This is that office to the north of the supply room. It's disconnected in the sense that they're both in the same warehouse chunk, but they're essentially got 4 independent walls and they're not on the same HVAC system, or not primarily on the same HVAC system. Here you'll see we have essentially 18 months of nothing happening in radon. Very little happening in TCE during this period, nothing over 1 micrograms per cubic meter. We certainly wouldn't have gotten excited about this in a commercial building. So we essentially see virtually nothing happening for 18 months. And then the TCE gets quite a bit more interesting in the winter of 2021. Very different than its behavior over here in the winter of 2020. And although it's noisy, it does look like the radon tipped us off that was occurring. Now, I will note that you have to be somewhat discerning to see that radon signal, in that it's not radically above the ambient outdoor range at this site. But if you look at it in this data plot, I think you would believe that there was a rise in radon out here in 2020. We tried to figure out what in the world could be going on here. Why was the winter of 2021 any different than the winter of 2019, 2020? And the one thing I could come up with, we did not directly measure moisture underneath this building. So I had to turn to satellite data. This is data that basically tells farmers how wet their fields are. Shallow moisture in the general area. And I'll clue you in that although we're only calling this Virginia Site A, you really want to look down here at this coastal area of Virginia. And the only difference we could see here, the TCE rolling average is the yellow. The only difference we could see between the winters of 2019, 2020, or one difference we could see, is that it was pretty dry in the winter of 2019, 2020, all the way through until about October to December of 2020. So we suspect that moisture levels may have something to do with this. We also know that there were effects going on beneath the slab at this building. There's some strange things about the way the building was built. It was originally built with the gutters running down through the middle of the building and discharging into the subsurface, rather than, people usually think about gutters going out in the parking lot. And there were some occasions where water was seen on the floor, et cetera. So why could this bathroom be different? Well, there's certainly a potential for preferential pathways. We were not able to ever find the smoking gun with the HAP site, but certainly as a bathroom, we would suspect preferential pathways may have a role, and that there are complex effects of water and moisture on radon concentrations. Let me see. Okay, here's the slide I wanted to speak to. So here we see plots of radon and TCE both in the Office 209 supply room area and near this bathroom. And we have less time resolution on this data, the radon data being taken manually once a month, essentially. And what you'd see here, if we look at the purple, is the radon, and the purple here is the TCE. So they tend to run together in this office and supply room area. While down here, if we look at the matched pair, ESV5 for radon is this golden set of data that hits this minimum down here, and ESV5 for TCE is up here running pretty level. So we do see a period where the radon was a poor tracer in the women's bathroom, and that seems to correlate to a time when the subslab concentrations were minimal. Let me come back here. I'm not sure I gave this slide enough time. So this is the same plot of TCE and radon in the women's bathroom. We've got TCE vapor intrusion ongoing. We set up the radon monitor in here. We watch it for 2 months. The radon is really not telling us anything, even though we have TCE vapor intrusion. And then all of a sudden, we do have, essentially, it seems like the radon starts to track with the TCE fairly well here. The other thing to note about this TCE pattern is that it's pretty abrupt on and off. That's a lot like Dr. Johnson thought Sun Devil Manor was, that there were essentially on periods and off periods for vapor intrusion. And so that's a little bit different than the stack effect driven pattern we saw in the supply room data. So that gets us to, why could this bathroom be different? It's certainly possible that the migration through this, through a preferential pathway could be what's making this different. It could also be changes in the water level directly under this bathroom. Okay, and this just shows it in an XY perspective. So here we have TCE on a log scale on the x-axis, radon on a numeric scale on the y-axis. Supply room, we've got a pretty good correlation. Office 209, fairly good correlation. And then up here in the women's restroom, we don't have a very good correlation. So here's the highest radon concentration, does not at all correlate to the highest TCE concentration. And similarly, if we come over here, here are some of the highest TCE concentrations, again, not closely correlated to the highest radon concentration. So essentially, this radon tracer is working in 2 out of these 3 zones. Indeed, it works some of the time in the women's bathroom, but it doesn't work all the time in the women's bathroom. So that is very much challenging us to understand when this tool is going to be optimal. And I think that it has something to do with changes in soil gas concentration and different factors affecting the TCE versus the radon soil gas. And I think the thing to keep in mind about this case is that the VOCs here are predominantly in the shallow soil in the beta zone, and we have very shallow groundwater most of the time. So how am I doing on my time here? All right, excellent time. So we're looking here at the Indianapolis duplex study. Many of you who've been to vapor intrusion conferences have seen this before, but I'm going to try to put a different lens on it, looking at this comparison between radon and VOCs. It's a 1915 duplex. The shallow soils are fairly tight, and the deep soils are fairly loose. The water table is typically down around 15 feet, but pops up and down as the nearby creek floods. We believe that the source is probably one of 10 historical dry cleaners that were up the street, and that transport probably occurred both in groundwater and on a neighborhood scale in sewers. So just look at what some of the soils look like. So this is a plot I want to take some time to unfold for you because it's complex. First of all, the black bars up here represent on-off testing of a mitigation system. So that black bar represents a period where the mitigation system, subslab depressurization system, had just been installed and was running. Then we put it into a passive mode in the period where this gray bar was. In other words, we just pulled the plug on a standard subslab depressurization system. And then in this empty area here, the mitigation system was, both the plug was pulled and it was entirely valved off, so it shouldn't have been doing anything. Then we're looking, the blue had to do with snow and ice events. I'm not going to talk much about that, but just so you know what's going on with those blue bars. Up here we're looking at PCE in indoor air measured by a gas chromatograph about every 2 hours. Down here we're looking at radon in the upstairs area of the structure and radon in the downstairs area of the structure. So a couple of things to notice. During the off period, or excuse me, during the on period, you see the mitigation system being turned on, and the radon really plummets. And when the mitigation is on, as indicated by the black bar, the radon mitigation performance is quite good. It holds it down both in the basement and downstairs as we'd expect. And indeed, the pressure field extension was fine here. With the mitigation system off, or in the passive mode, we see substantial spikes back up of the radon concentration. And we see here two peaks that seem to be mirrored between the PCE trace and the radon trace on a scale of weeks. Let me just give you a sense of the time scale here. So there's December 12th, New Year's Day, January 21st, February 10th. So these are roughly 1 week kind of bar spacings. So, and then very interestingly, we have a period here where we've got the mitigation system running full bore. It's doing perfect for radon, but we have some spikes back up of the PCE. So we're not capturing the PCE reliably here, even though we have quite good performance for radon. Sorry, I got to advance the slide. Here is the same thing, except we are now looking at the chloroform, which is the other VOC present at this site. You see the same two peaks in the mitigation off period, but much weaker peaks for the chloroform, if any, out here in the period where the mitigation was on. So I'm going to step back now to a longer time view to try to figure out what's going on with the radon and the chlorinated solvents, since we looked at them in a really intense time period. So this is the start of the study, and this is PCE. So PCE really essentially plummets over the first 6 months that we were observing this building, and hits a low in the summer, comes back up in the winter, but not nearly as high. Then this is that period of us turning on and off the mitigation system, a couple weeks on, a couple weeks passive, a couple weeks on. And you'll see PCE concentrations obviously jumping up and down as we turn that system on and off. And then finally we ran through a period of the system off again. We see the PCE come back up to relatively high levels with the mitigation system turned off. And here we're looking at 6-month periods on these between each line. So we have a period here of about a year with the system off, PCEs come back up. Then we turn it on and don't mess with it, just leave it on full time, and we get pretty good performance in PCE reduction when we're leaving the system on full time. Same thing here for chloroform, a very similar pattern. Under natural conditions, drop off in concentration in the first year, bottoms out here in the summer, comes back in the winter. This is the period of on-off, and then it's come back under natural conditions. Then we turn on the mitigation system and we knock down the concentrations nicely. Emma, would you mind seeing if you can advance the slides, and because that'll let me stay where I can do the. All right, there we go. So here is the radon over a corresponding period, and what we'll see here is that the radon concentrations are very constant during this whole period, except for here where we've got the mitigation system on. Now I haven't shown you the period where the mitigation is back on for the radon, but radon, the mitigation system, whenever it was on, worked great for radon, and much more temporal variability for the VOCs. Advance slide, please. So here's what's going on in soil gas, and it's a complex story. Starting here at the beginning of the study, each of these different colors represents a different subslab soil gas port. You'll see this black bar, subslab port 1. If I follow the black story, it comes down. In the summer of the first year of monitoring, it's hit a minimum, and now it's coming back up into the hundreds of micrograms per cubic meter. While these other locations in the same, underneath the same duplex, the red and yellow, start low, and then they come up in the summer and drop back down in the winter. So they're doing very different things. The other thing I want to notice here in this slide is let's look at the purple data, for example. Here we're up, here during the whole first year, we're in the 100, 200 kind of league. We never see anything higher than that, and then we start messing with turning on and off the mitigation system. And all of a sudden, there's purple data, and the yellow data exhibits some concentrations up here in the 1,000 range. So what we believe we're doing, indeed, we believe we've seen concentrations with the mitigation system going on and off that were higher than anything we saw under natural conditions. So we believe that we were actually pulling VOCs towards the house, and that turning on and off the system 2 or 3 weeks on, 2 or 3 weeks off, although it was a desirable thing perhaps from a scientific perspective, would be a really bad thing to do from a personal protection perspective. Now looking at the subslab concentration over comparable months in different years. What I want to show you here is that the radon in the month of December, except when we had the mitigation on, was almost the same in 2011, 2012, 2013. Here we're looking at the month of January, radon in soil gas. I think you can see in 2011, 2012, 2013, 2014, we have basically the same radon concentrations no matter what we do and no matter what the weather's like. While the TCE concentrations have much more variability if you compare the December 2010 to December 2011, both of which were natural conditions, and then to this December 2013. Similarly here, if we compare our TCE concentrations in January, we've got substantial differences. This 2014 is probably because we've already done some mitigation down there, but want to illustrate that there is much more variability in the supply of the VOCs in the immediate subslab area to be drawn into the structure than there is in the radon. Essentially, the radon is coming from the soils within a couple of feet of the house. It's essentially a constant source, geological source, where the PCE is being drawn in probably from a distance, probably with some role of the sewer not getting directly into the house, but migrating at least from the street or the distant dry cleaner to the subslab area beneath the house. And that's affecting the available amount of VOCs beneath the subslab. Go ahead and advance me. This is the same situation, except now we're looking at indoor air data and comparing to screening levels. Again, the radon quite uniform over these 4 years of Januaries. Radon quite uniform here over 4 years of Januaries now on the first floor. This up top here, we're looking at the basement and then the first floor. So a pretty uniform story for the radon. Under natural conditions, we had a big swing in the PCE between January 2011 and January 2012. Somewhat of a bounce back up in 2013 with the mitigation system off. But a very dramatic difference here. And we looked at it, and there was a dramatic difference in the severity of the winter. That was one thing we could say was different between 2011 and 2012, was that there was probably a 15-degree difference in the severity of the winter. Go ahead and advance.
10 minutes.
10 minutes. All right, we're doing good. Here we're looking at what we call in the vapor intrusion field the attenuation factor, the ratio of the indoor air concentration to the subslab concentration. We often use that as an estimating tool. We often start with subslab concentrations and then try to see what indoor concentration we might expect. And I'm going to focus here on the subslab to indoor air attenuation factors. We have red representing times that the mitigation system was off and green mitigation system on. And then you see here chloroform, radon, and PCE on the two different sides of the house. This 420 side of the house was not directly heated. We didn't essentially pay to put the furnace back into service. And here the 422 was run much more as a normal householder would do. And so the point here is that the radon and PCE attenuation factors across the building envelope are quite similar, even though there's very big differences in how much supply you've got at the subslab. Go ahead. So we have a mitigation system that met conventional depressurization tests and worked pretty darn well for radon. It didn't work terribly well in the first year of turning it on and off for VOCs, only about a 60% benefit. But once we did turn it on and run it constantly, it did have good performance. We saw higher concentrations in soil gas of the VOCs with the mitigation on than we did with it off. And we saw a higher flux estimate of PCE through the duplex and the mitigation system with the system on than with it off. So we believe that we were essentially moving VOCs from the plume or from perhaps the sewer system towards the structure. Go ahead. We did a lot of fancy statistics, which I have mercifully spared you from today, time series analysis. But what that showed us was that the change in temperature was more important than the absolute temperature. So the getting colder was more important than being cold. And similarly, change in barometric pressure seemed to be correlated with VOCs, as well as change in radon concentration was better correlated to VOCs than the radon concentration as an absolute variable. Next slide, please. And so that's what this shows here. This shows on the x-axis increasing radon concentration week over week, decreasing radon concentration week over week versus decreasing PCE versus increasing PCE, and the colors represent mitigation on and off. And we have a general correlation that when radon is going up in indoor air, PCE is also going up in indoor air. Next slide, please. But the proportion of the variability of the VOC concentration in indoor air that we could get out of any one variable, even radon, was pretty small, only 30%. And why is that? Well, I think the folks in the radon field have kind of known that for a long time. Going back to this Living Radon reference manual from 1985, it talks about 13 factors affecting radon in the indoor air. Well, you can be fairly understanding of why we only have 30% explained by one variable if we have 13 factors going in to explain the indoor concentration. Let me see if there's new information here that I haven't spoke of. Essentially, the sewer line did play a role. There is a paper out to explain that. PCE is arriving at groundwater depth, we believe. Chloroform likely had a shallow source, perhaps municipal water or sewer lines. And so these differences in the supply or source of the soil gas concentrations for radon and VOCs is what I think explains where we have correlation and lack of correlation. So radon and VOCs behave similarly across the building envelope in this case, but the concentrations in the subsurface feed that are controlled by different factors. Therefore, I think we can use radon as a semi-quantitative tracer, but we should be cautious about using it as a long-term quantitative tracer. And monitoring radon and other low-cost indicators such as temperature and differential pressure give us more information at a lower cost to understand what's going on in the building better. I think we can say that you're certainly no worse off with that information and maybe substantially better off. Just a quick plug, we are collecting very similar data set in Fairbanks, Alaska. This just talks about the type of building and the square footage over a VOC plume. Got references, can point people to references for both the vapor intrusion, the Virginia site, and on the next slide, the Indianapolis duplex is the subject of 3 EPA reports that will certainly cure insomnia. And standard disclaimer, this does not represent EPA policy. And some thanks to both the folks who funded this work as well as the folks NatFac Midland and the Mapleton Fall Creek Development Corporation who helped us get into these buildings, and people who were involved in these projects over the years. Henry Shuver and Ron Mosley have been guiding lights of this over a long time. So I hope I've left a couple minutes for questions. And I also welcome observations. If people want to stand up and say, "You're completely crazy," you're welcome.